Hello and welcome back to COG 376. We are going today to talk a little bit more about how to use regular expressions. To follow along with this demo, this time we will need to be using the installed version of Python. So go to the website. In fact, I can pop that up real quick. This is a new one. Beep. Couple notes as I do this. Fine, St. Patrick's Day, thanks. Couple notes as I do this. Go to python.org. I've made the screen recording size a little bit smaller, which for you will translate to a little bit larger text. Also gives me a better space to have some notes on the side, so we don't have a cluttered view, and I can show you things as we need them. So go to python.org and where's the download? Let's see. Where's the simplest install? All releases, I guess. Yeah, just get the one that is for your system, Windows, Linux, Mac. If you are on a Chromebook, there is an alternative way to do this. We may need to talk, though. I also might just post a walkthrough of how to do that on my website somewhere. So, but anyway, the idea is that once you've got it installed, again, you can, as in that last demo I showed, you can run idle. So these are both the same program, idle, running. This window is the shell, and this window is the script I'm going to use. So what are we doing? First thing we're going to do is import a package. So this is a little bit different idea. Packages are sets of code that have been written elsewhere. You might install them yourself, but Python also comes with a whole lot of them that it doesn't necessarily load every time, right? So if I want to use, for example, flashing forward, regular expression.search. If I call this right now, there's no such thing as RE. The package that we want to import is called RE, i.e. regular expression. So now if I call re.search, it's still going to blow up, but this time you see that it's not that RE doesn't exist. It's that, hey, you called it wrong. You did not give me a pattern, nor did you give me a string to search that pattern for, or search for that pattern within. Yeah, grammar is hard. So here's the thing. Here's how we're going to do this. I'm going to keep writing things in the script, just so we can keep track of what overall we are doing, but we're still going to play around in the shell as well. So how do we use regular expressions? If we remember, in fact, I might even pull up, go to my own website here, take us through COG 376, and we will pull up the regular expressions intro. Remember some of the basics, and I'll be popping this in and out. What are we doing? We are creating a pattern that can scan text for different shapes, right? Different patterns of text-based language. We've got a whole bunch of things available. We got meta characters that can represent, say, remember, period is any character, plus means there must be one or more of the thing we just saw, etc. So let's do some of the basics just to show it off. Just trying to tuck this away. So let's have a string. Here's some text equals abacaba. We're trying to find, is there any segment of this text that has, let's make something up, but what's a unique element of this text that you might want to see? How about something where B, I'm just typing openly for now, but B, any character C, right? If we remember some of the meta characters. does this exist in the string? We know it does, humans, pretty quickly, because we know that, oh, there's a B, and then the C comes there, and there's something in between, it doesn't matter what. So let's write that as a pattern. Some pattern equals B dot C. Now, in regular expression land, we typically write things with the slashes, the 4 slashes on either side. You don't need to do that in the Python implementation of regular expressions. So this is the text that we're going to search, and this is the pattern. So let's find out. I guess I'm gonna work primarily, now that I think about it more, I'll work more in the script than in the shell, but it'll still be there for us to screw around with. So if I want to find the pattern in the text, I do re.search. Actually, I keep going back and forth on whether or not to play around here. So let's load these. Let me load that, and then load that. I'm just copy pasting here. Okay, so now some text exists and some pattern exists. Great. So now let's call re.search. We're going to load, so the first thing it wants is the pattern, some pattern. And then the second thing it wants is what text are we searching? So some text. What happens? Aha! So this is telling us two things. One, it's saying, hey, I actually found something. I returned this object. Now, you don't have to dig too deeply into how objects work just yet in Python land. In fact, we probably won't be doing that. This is not a software engineering course. But it's important to recognize that just like there's really, really basic things like numbers and Boolean values, and there's slightly more complex things like strings, there's also even more complex things that are objects that have all kinds of features. I can show you real quick. Let's save this to something. I'm just going to recopy my last entry, and we'll say match, some match equals. So we've saved the output of this. So if some match, I can dir it, some match. That's the trick you can use to look inside. I'll tell you right now, there's a little bit too much here. This is not what we are dealing with. We're not going to be using all these different features, but something to note is that some match makes it so that you can access what's inside of it. So some match, kind of like you might do with a list, the 0th item of some match is the matched text. Yay! Okay, so now we're seeing I've gone into the string, I gave it a pattern, and it found it inside the string. Very good. Let's move this over to our sample script. So now we have a match. Now, what if I want to match a different pattern that doesn't work? So let's do other pattern equals, let's say we're trying to find b.d. We already know there's no D in this string at all, but let's do it. So some match, or no, other match, right? In fact, I'm going to change something here. I'm going to make these underscored so that you don't have to deal with blinding mishmash of text. Other match equals, I'm just going to steal it. Oh, also, I need to properly refactor all of my variables. Sorry, dog. Okay, so instead of some pattern, other pattern. When I do this one, in fact, I'm going to save this, and I'm just going to run it. So you can hit F5 to run your full script. Nothing's happened because we don't have anything printing. It just ran each one of these instructions, and now it's sitting here waiting for us to talk about it. So if I look inside of some match, we have the object. There was a successful match found. What about other match? Ooh, there's nothing in there. So that's a little confusing. This is now other match. When the re.search function returned, it came back and said, I got nothing. And so other match is now, it's a defined variable, but there's nothing in it. That sounds like it's useless in some ways, but there is a way you can use this to sort of as a Boolean check to say, did this succeed or not? So what you can do is, I'm going to be very explicit. There are shorter ways to do this, to using if statements and stuff, but here's what you can do. You can say, so if we want to know, did this search succeed? We can use the none concept. None is sort of a placeholder for the idea that there's nothing there. So, for example, sum match equals none. This is asking, hey, is there nothing inside of sum match? If there is nothing in there, it'll come back true. So there is something in there. How about other match equal none? This will be true because the other match has nothing in it. That second match that we know the pattern doesn't exist ain't there. Ta-da. Or maybe the opposite of ta-da. So, other match equals none, blah, blah, blah. Yes. So the way we would maybe frame this maybe more positively is oftentimes we're going to want to write something that's like an if statement that says, hey, if you found something, do this. If you didn't find something, do this. So what you'll do is something like sum match does not equal none. Okay, so this is the true statement. This is what we might check before we move on. I'm going to demonstrate that doubly here by having a little bit of printing going on here. The way you would be careful with this and check it would be something like print. So here's the thing. If sum match does not equal none, print sum match sub 0. What is that doing? Oh my goodness. What this is doing is saying, hey, if this thing exists, show me what was found. Otherwise, don't do anything. Because if you try to call, for example, oh, hey, show me what's inside of this failed match, other match sub 0, it's going to blow up. Because it's nothing. There's nothing in other match, so you can't address it. You might write code that wants to address the match, so you first have to check, is there anything there at all? So what this code is going to show, if other match does not equal none, print other match. Sorry, typing's hard. So run the whole dang thing. I'm going to give sum match, and then this one will be other match. So F5 it, show the whole thing. We see that sum match pops up because it actually exists. The other one does not. This is just a handy way to avoid errors, but also give you a default way to behave if you're writing a program that says, oh, I'm trying to match things, but I failed to match anything this time. I should still probably do something. So that's some of the super basics. Now let's get back on some of the things that we have done in the past. So I'm going to copy some things over here that are from the lectures. So text line, some regex from lecture. Here's a text line. It's going to have Google, John Linstead at gmail.com. Actually, that should be oswego.edu. That other one doesn't work. Haha, take that. So, it's a little bit long. Yeah. Okay. So just a bunch of patterns, right? Things that we already kind of know. And we're going to see if we can match them using some constructed patterns. So, I'm not building them from scratch, but we already did these in the lecture, right? So what's this phone pattern showing? This is digits, I want 3 of them, dash, digit, I want 3, dash, digit, I want 4. That will capture the phone number, one hopes. Let's find out. So if, I haven't done the match yet. Yeah, we'll do it. So phone match equals re.search. We're going to search phone pattern inside of text line. Okay, and now let's write a real quick little thing. If phone match does not equal none, if we have something, then show me what it is. Print. I'll give it phone match, and we will print out the contents of phone match at position 0. Okay, let's run it. What happens? Oh, what's up? Just for the sake of, I'm going to go ahead and print the text line, just so we can see it in the output here. So I'm going to run it again. F5 me. Okay, so there's the string we're searching, and look at that. I snatched out the phone number from this long string of text. My system, the regular expression, went in and said, I'm looking for phone numbers, and it found one. Awesome. Let's do more things from lecture. I'm going to just start copying these over from an external document. Very similar patterns, although I have slightly altered some of this. We're going to do each one. So web pattern, remember, we'll walk through it in a second. I just want to write web match. Okay. So, and save often. Remember what the web pattern was doing. It was saying, I need www dot something. We have this new category of only A through Z, 0 through 9, and dashes are allowed, right? So this is, we're defining a class of character that's allowed. We need at least one of those, if not more. And then we need a period, and then we need our com, org, gov, or net, right? So this is a little subset, a sub-pattern, where we have ors in there to help figure out which thing was matched, or which things are viable. So, good, cool. Let's see if it works. Keep adding on to our script. The phone match got that. The web match got Google. Woo! Keep going. Let's do more. We're going to get the text file pattern out of there. And this is slightly modified from the lecture. It's just a little simpler. Text file match. Oops, I didn't fully copy that word, text file pattern. Okay, and then again, we're going to make it clear, this is text file match. Okay, what's the text file saying? Well, all it says is there needs to be a .txt, and everything else, there needs to be at least one character, otherwise this is not a file. It's just an extension. Okay, and a word character, right? So, we do the search through the line, save it and see it. Let's find out. My system didn't like that. What happened? What's your problem? Oh, I'm trying to run it from inside. Silly. Run it there. We grabbed out the text file. Fantastic. All right, final one is the email pattern. This was the most complex one, also because I took it from a more robust thing than my own work. Okay, what was this about? Oh, crap. Okay, so there's a lot of things that you can have happening before the @ symbol in email. Looks like pluses and minuses, percents are good, underscores, dots, and word characters. Okay, cool. We need at least one of those. We have the @ symbol, which must be there. Otherwise, this is not an email address. Then we have the domain, right? So W's, dots, and dashes. Okay. That all works just fine. At least one of those, a period to separate, and then 2 to 4 just letter characters. So this is sort of a different way of capturing com and org and gov, because there are more things now than there were. But the whole idea being this should match on email patterns. Let's do it. Get that email match. And again, we want to see, come on. Man, it scrolls funny. I think Mac is trying to do some inertial scroll things that it doesn't like. So, email match. Okay, run it one more time. It done it. It got my email address out of that line of text. Woo, wonderful, excellent. Fantastic. So I hope this is making sense. What we're doing, top to bottom, is we are saying, we are saying, I want to, within a line of text, I want to search for certain kinds of patterns. I want to be able to extract phone patterns if they exist. So to do that, I create the phone pattern in accordance with regex. I create a new variable to hold the match object that the regular expression is going to find. And to do that, we do re.search, and we say, here's the pattern, here's the line of text, give me what you got, right? And if phone match is not nothing, if something actually went in here, that means that the search was successful. So now we say, hey, what was in there? And we do that by saying, hey, phone match sub-0. That gives us the very first thing inside of phone match. You can think of it as a list. I showed you that it's an object, but you can just think of it as a list for now, because that's the only way we're going to be using it. So this recaps us up to the point of having implemented some of the stuff from lecture. Cool. So now let's dig into a little bit more. There'll be more notes in the margins and like the comments and such here in the version of this I post. So no worries for now if this is a little dense. Just keeping track of where we've been. Okay, so new idea. 1. Capturing information from regex. So we've already shown that these regular expressions are able to snip out specific substrings, right? And this works just fine. This is great. But sometimes we want to get even more specific, or we want to match more and pull things back. Remember how Eliza can find words that you've said and then kind of mirror them back to you, right? So let's look at that. Oop. Come on, scroll boy. Okay, so one thing that we've already done, which is cool, is look at the pattern for web. This is how you get extra sub-content out of the match. Whenever you have parentheses, that will give you a sub-item. So right now, right away, we can say, hey, print me the whole web match is web match sub-0. Also print me just the domain web match sub-1. So the trick here is anytime you have parens, just parens, not the square brackets, remember that's for defining a class, and the curly braces are for defining numbers. Just for these sub cases, these sub clauses, you can say, hey, store that as well. So let's do it. Let's see if this works. At the bottom, remember it's running everything, but we're looking just at the bottom. The whole web match was google.com. Just the domain was com. I guess that's top level domain. Be more accurate with our terminology. So what you're seeing here is that you can have a good match, and you can match a whole pattern, and then you can start to extract data from that pattern. This is powerful. This is the most important part of language, right? We are taking patterns of text and we are extracting useful info from it. Let's continue along this line. So let's do one, let's construct a new one. Area code pattern. We're going to do something just like the phone pattern, but we want to be able to extract the area code from the pattern. How do we do that? Well, remember, anything that gets wrapped inside of, I'll leave that uncommented for now. Anything that gets wrapped inside of the parens will become a segment. We can do this, and that's all it really takes. Because remember, this is just saying, hey, do me a substring. Sometimes you need that for things like doing com or org or gov, and sometimes you just want it so that you can extract this later. In fact, I can make it so that we can extract all of them. I don't actually remember the names of the other segments of phone numbers. Used to be important, but now it's kind of irrelevant. We all have phone numbers from wherever we moved from, right? So here's what we're seeing though. This is the same pattern as the phone number pattern, but it has a little bit more, it has a few more stops in it. So let's do it. I'm gonna just grab this out so we don't take too long. And now we can walk through how many items should be available in this. The whole thing will be in position 0. I guess I should put whole number. I'm going to just copy paste myself. In the first slot should be the area code. Second slot should have the next 3. Third slot should have the next 4. Let's see. Oops. 2, 3. So area code, like region digits, specific digits. Sorry, those aren't accurate. I don't know exactly what those are called. I don't study telemetrics. So F5, hey, look at this. The whole phone number, the area code, the region digits, and the specific digits. Actually, that might be extension. Whatever, that's my extension at least. We have done one pattern, but been able to extract 3 useful bits of information from that pattern, separate it out into more, useful code. So, not code, data is a better way to say that. Okay, so let's try to get this in a little bit more into processing more natural language. Let's move in that direction. Trying some natural language. Let's see here. Let's say our user says, did you know that I have 2 cats? Oops, not sir, you sir. So what's happening here is I'm communicating something to you. What are you going to take away from this? What information is being conveyed here? The information is ownership. The speaker has ownership of something. What? Cats. And how many? 2. We can use a regular expression to pattern match this and extract that data. Let's talk about the parts of this. So, what are the parts? I'm just going to put them in comments here. Did you know that? This is just sort of fluff, right? That's not super important. I mean, it has some content in it. There's some information there, but it's not really the core of what's being communicated. We can mostly discard that. Second, we have I have. This is the part that indicates what is actually being conveyed here. This is how you might match the whole pattern and say, oh, this is an important piece. I should probably match on this. So this is the key idea about ownership, right? This is what we're communicating. We also have 2, the count of the thing that I own, and we have cats, the kind of thing that I own. Okay. We, as people, have just walked through chopping the sentence up. Now we can construct a pattern, or we can at least try, to capture this from the language that has been spit into the system. So let's make one. How do we capture each of these? Well, to start, we can do dot asterisk. So this is just going to be grab everything up until the important stuff. Throw it away. We're not going to save that. That's not the part we're matching on. We're just saying, hey, there can be anything before this, but there needs to be something before this. Or there doesn't need to be anything before this. It can be anything. This is just a way to make sure that we're matching the string, but throwing things out that we don't want to focus on. Now, we do need the words I have, because if, let's see, I need a space there too. Because if I have something, that's different than I was something or I went somewhere, right? And it's very different from you have something and you went somewhere. So those two words must be there, and they more or less have to be kind of in that order. This is how people would typically convey this kind of thing. They might also use something like I own, but we're going to, for the simplicity's sake, we'll just leave it at I have. The key match, right? This is what tells us what kind of information we're getting. I should probably carriage return that. Okay. Now we also have, well, what do we have next? We have the number, right? I have some number of something. How do we match numbers? Well, first of all, we want to capture this. So this is where we are going to, this is some of the information we want to extract, right? The system needs to be able to say, you have 2 cats, right? 2 objects type cat, number 2. So we need to be able to extract it, so we use parens to start. We will also need to capture, so these are digits, right? We want to capture digits that have been typed in, but we want as many as the user puts all consecutively. So at least 1 digit, if not more. This is the next piece of the regular expression. So at least 1 consecutive digit, if not more. Okay, and now we got to capture the kind. Well, this is also fairly easy because it's very similar, except instead of digits, we're looking for word characters. At least 1 word character for kind. That's it. This is a pattern. It ain't perfect. There are some weird issues we might run into with like plurals and tenses, and what if they say they only have 1? You know, it can be fine. There are ways you can, after this, if you were really, really developing this, you might put it together. But let's staple all these together into a pattern. Owner pattern equals dot asterisk I have space at least 1 digit space at least 1 word. Oh, at least, not just 1, at least 1. There. Owner pattern. Okay. Let's see if this works. Owner match equals re.search owner pattern user says, right? There's the match. Let's print the pieces of this. I'm just gonna copy that over real quick. Run it. Oh, I did it again. F5 in the script. Oh, I blew something up. What did I blow up? Oh, I changed the names here. Owner match. Owner match. Owner match. Okay, run it again. Did you know that I have 2 cats? 2 is the quantity, cats is the item. Ooh, so now I'm going to borrow my own code, and we're going to put this in a constructed string. Remember, we can build strings using the plus signs. So let's have the system spit this back out in a nice way. Let's say print item space plus owner match 2, right? So the second item here contains the word cats. Count, so comma space count owner match 1. Let's do it. Oops, save it, F5 it. Did you know that I have 2 cats? The user says. Item, cats, count 2. We have found a way to extract relevant data, relevant information from this attempt at communication. This natural language sentence has conveyed something that the system has stored. Okay. Let's do a little cleanup and introduce you to one nice, interesting little idea about... One thing here is that this is a little bit awkward to write. There's a nicer way, a more clean way to consider writing something where, you have a string, but you want to dump some variables into it, right? Let's just do a quick tutorial on formatting text. So the idea of a formatted text is something like this. I can say, there was a %s in the %s period. That is a string with 2 slots waiting to have something put in them. To put something in them in Python, at the end of the string, you do the % operator. And now you can give it a little list in parentheses of cat, comma, street. When I hit enter, this is going to fill in the string. There was a cat in the street. This is so useful because there are so many templates where you might want to fill information in. So let's just redo that same one using a formatted string. Oops, this is owner match. Okay. So this is going to print the same thing twice, but this time it's a little bit easier to kind of understand it. This is the string, and these are the slots that are going to get filled up with the information we want. Now remember, the second one is what contains the item. The first one is what contains the count. So run it again. Yes, good. They are doing the same thing. I just wanted to show you this because it's just a little more intuitive once you start using it. So before we go, I want to, let's wrap this up in a function and play with it a little bit. How do we function? Well, let's play with this in a function now. So what I'm going to do, I'll type it all out. Define, we're going to call this item parse. We're trying to parse a string for items. User input. Okay. Very first thing we do is we capture the match, right? Match equals re.search. Now we could define the pattern out elsewhere, but I'm just going to hard code it right into the function. So this is the pattern that we're looking for, and this is we're taking the user input and doing the match on it. So that's the first thing. We grab the match. Now, if match does not equal none, as always, oops, not equal none. So if we found something, print our pretty string. So item %s count %, what's s again, right? Yeah. And then we do the % operator, and then we say, give us the match sub 2 for the item, give us the match sub 1 for the count. If we found a match, that's what we do. Else, we might still want to do something, so we can say print, not primpt, I got nothing. the system will at least give the feedback that it didn't understand what you said. So here we go. Let's save that and let's screw around with it. Run the whole thing. Ugh, as always, I go to the wrong place. Run the whole thing. Cats, count to blah, 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 blah. It doesn't show it, but item parse exists now. So parse. I can say, hey, it's like, hey, give me the string. Where's the string, man? Okay, let's throw something at it. How about item parse, I have just one cat. What's going to happen? Do you think it'll succeed? How does the pattern match? I have, actually just is going to be a problem. So forget that. I have one cat. We'll just leave it at that. Of course, my first example breaks it. So, but let's show that. Let me show you how I'm bad at examples. So cat, count 1. Cool. It extracted it. In this case, I got nothing because I have inserted something that doesn't really match the pattern. We could probably fix that. What if we did? No, we'll wait. We'll wait on that. So there it is. I got nothing out of that one. How about item parse? I have 30 dogs. How about I think I have 30 dogs? Will this parse? It's got a bunch of junk. Who cares what you think? The question is I have. And then the pattern, 30 and dogs. This should work. Let's find out. Item dogs, count 30. Item parse. I have 500 capybaras, and I just don't know what to do with them. This is going to work, I think, because the pattern still matches. And then we have a bunch of junk at the end that trails. This is still the information that you, the human, would extract. Haha, item, capybaras, count 500. The information has been transferred. We understand it. And so too can your system. Okay. That's it for today. Follow along with this. I'm gonna post the script online, and just give it a shot. These are the things you should try to play around with. The next assignment will have you writing your own chatbot using this. And again, you know that I will walk you through. But I hope you're starting to see how this kind of system could have lots of different patterns that it might want to match, and lots of different answers that it can infill snipped text from the user. Okay, that's it. Thanks so much. Don't need to save the shell. Cancel. Take care, everybody. Have a nice day.